This video is an introduction to logarithms. First question, what the heck is a log? Logarithms are inverses of exponential functions. They undo exponential functions. And they're really useful when we're looking at exponential functions because they change so quickly. It's sometimes hard to read them. If we put this in what's called a logarithmic plot, which is not something we're going to be doing in this class, it really pops out what the graph looks like, and it's much easier to read once you learn how. You're already familiar with two logarithmic scales. The pH scale, which measures the acidity of substances. So lemon juice has a low pH, meaning it's highly acidic, and I think soap has a high pH. Milk, there's an example. So milk has a high pH. It's more base than acid. We also use logarithmic scales to measure earthquakes, the Richter scale or the moment magnitude scale. And why we do these things is because we want an easy way to represent a really big change in the magnitude of something. Lemon juice and milk, I should have looked up those numbers. The numbers aren't terribly far away from each other, except in a logarithmic scale, a single change of one number represents a jump of 10 times the strength. If we have a 5.0 earthquake versus a 6.0 earthquake, the 6.0 is 10 times as strong as the 5.0. And this 10 is the base. So there's nothing magical about the number 10. We pick it a lot because we have a base 10 system, but the base could be a different number too. Okay, but what is a logarithm? I said it undoes exponents, and here's how. For a moment, let's think about logs as just a way of counting by numbers. This will make more sense when we actually do a problem. If we take some number raised to a power and it equals something else, like 2 to the third power equals 8, we can write this as a logarithm. And what the logarithm would look like is we take whatever the base is and we write it down here. That's called the base of the logarithm. So this would be log base 2 of the number 8 equals 3. The base over here becomes the base of the logarithm, and then these two numbers do a switcheroo. So what a logarithm means, it's a way of counting in a multiplication way by the base in order to get to the number that you're taking the logarithm of. And so what I mean by that is if I'm multiplying by 2's, how many 2's do I multiply to get to 8? Well, I multiply by 3 of them. 2 times 2 times 2 equals 8. And I've inadvertently done our first problem. Find log base 2 of 8, which means that 2 to some power equals 8, where we multiply by some number of 2's in order for that to become 8. So our answer for this first question is 3. This next one, log base 3 of 81. So I'm multiplying by 3's in order to get to 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. So how many 3's we had? We had 4 3's. 3 to the 4th power equals 81. Or multiplying by 3's to get to 81, we need 4 of them. This next one, I encourage you to pause the video and try yourself. Log base 5 of 25. That's asking how many 5's do we multiply by in order to end up with 25? 2 of them. 5 times 5 equals 25. This is a sentence that one of my students came up with, and I really liked it. They were trying to explain this back to me after I tried to teach it in class, and they said, the log is the exponent the base needs to equal the number given. Actually, let's go back to some of those problems. They said the log is the exponent that the base needs. So there's our exponent. The log is the exponent of 2 that the base of 5 needs in order to equal the number given, in order to equal that 25. Let's do a few more problems. Find log base 10 of 1,000. So how many 10s do we multiply by in order to come up with 1,000? Well, 10 times 10 is 100, so that's 2 of them. If we multiply in a third 10, we end up with 3. 10 to the third power equals 1,000. Notice I'm just fluidly switching back and forth between exponential form. So 10 to what power equals 1,000 versus logarithmic form. Log base 10 of 1,000 equals what? 3 for both of those. Log base 2 of 2, an interesting thing happens here. So 2 to what power equals 2? Well, 2 to the first power equals 2. We only need to multiply 1 2 in there in order to end up with the answer of 2. This last one, log base 3 of 1/9. So this is an interesting question because how can we take 3, I'm going to say 3 to the x, and have that equals a 1/9? Think about what you know about negative exponents. What we're doing is we're multiplying backward, or dividing. This is the same thing as 1/3 squared, which is the same thing as 3 to the negative 2 power. Log base 3 of 1/9 equals negative 2. We need to have 3 to the negative second power in order to end up with 1/9. Thank you.